We now discuss the solution of a problem from the section Differential Equations. This question has appeared in the Joint Entrance Examination Main held on 28th June 2022 in the second shift. The problem is related to linear differential equation. The given question is, let the slope of the tangent to a curve y is equal to f of x at the point x comma y be given by 2 times tan x in brackets cos x minus y. If the curve passes through the point pi by 4 comma 0, then the integral 0 to pi by 2 y with respect to x is equal to. We are given 4 options. These are the 4 options: option A, option B, option C, and option D. And we have a curve y is equal to f of x. The slope of the tangent to this curve at any point x comma y is given as 2 times tan x in brackets cos x minus y. It is further given that this curve passes through the point pi by 4 comma 0, then required to compute the integral of 0 to pi by 2 y with respect to x. We now discuss the solution of the problem in detail. We have dy by dx, which represents the slope of the tangent to the given curve y is equal to f of x at any point x comma y. It is given that this slope dy by dx is equal to 2 times tan x in brackets cos x minus y. This can be written as dy by dx 2 times tan x minus y is written as it is brought onto the left hand side, and it will be plus 2 times tan x multiplied by y is equal to 2 tan x cos x. And 2 tan x cos x is 2 into sin x by cos x multiplied by cos x. This will be 2 sin x only. So dy by dx plus 2 tan x multiplied by y is equal to 2 sin x. And it is a very familiar differential equation. It is of the form dy by dx plus p of x into y is equal to q of x. Here, in our given differential equation, p of x is 2 times tan x, q of x is 2 times sin x. What is it? It is a first order ordinary linear differential equation in y. Now, how do we solve it? To solve such a differential equations, we first find integrating factor, that is equal to e power integral p of x with respect to x. After we get the integrating factor, the general solution is given by y into integrating factor is equal to integral of q of x into the integrating factor with respect to x plus c, where c is the constant of integration, which is arbitrary. Great. So in our case, the integrating factor is e power integral px dx. Px is 2 times tan x, so e power integral 2 times tan x dx, and integral 2 times integral of tan x dx is ln of secant x. E power 2 into ln of secant x is equal to e power ln of secant square x, and that will be equal to secant square x. Thus we have obtained the integrating factor. The general solution is y into integrating factor, that is secant square x, is equal to integral of q of x. Q of x is 2 sin x into integrating factor secant square x with respect to x plus c. This is equal to integral 2 sin x into secant square x. Secant square x is written as 1 by cos square x, and sin x by cos x is tan x, and 1 secant x remains there. So this is integral of 2 tan x secant x dx plus c, and 2 times integral of tan x secant x with respect to x is secant x. So this will be 2 times secant x plus c. Thus the general solution is y times the integrating factor secant square x is equal to 2 secant x plus c, where c is the constant of integration, and that is to be determined with the help of the given condition. We have the general solution, right? We are given that this curve passes through the point pi by 4 comma 0. So in the above equation, put x is equal to pi by 4 and y is equal to 0 to obtain c. So y is 0, 0 into anything is 0, 0 is equal to 2 times secant x is pi by 4, secant pi by 4 plus c. And secant pi by 4 is root 2. So 2 plus c plus 2 root 2 is equal to 0. That will imply c is equal to minus 2 root 2. Now take this value of c and substitute back in the general solution. Then you will get a particular solution. Y into secant square x into 2 secant x minus 2 root 2. So that is the curve right now for us. Now what is to be done? So you have to integrate y dx. So for that we obtain y. So multiply throughout by cos square x. So it will be y is equal to 2 secant x cos square x is equal to 2 cos x minus 2 root 2 into cos square x. Now integral 0 to pi by 2 y dx, that is what is required to find. So that is equal to 2 times integral 0 to pi by 2 into cos x, the first term, minus 2 root 2 integral 0 to pi by 2 of cos square x dx. So integrate the first integral. The integral of cos x is sin x to be evaluated between 0 to pi by 2. For 2 cos square x, you write 1 plus cos 2x. Right. So this will be 2 into, after the integration, sin x to be evaluated between the limit 0 to pi by 2 minus root 2 cos square x. For that we have written 1 plus cos 2x. Now evaluate. So 2 into, for the upper limit sin pi by 2 is 1, 2. For the lower limit sin 0 is 0. So you will get only 2 here. Minus root 2 into integral of 1 is x. Integral of cos 2x is sin 2x by 2 to be evaluated between 0 to pi by 2. Now when x is pi by 2, for the upper limit x is pi by 2 plus sin of 2 times pi by 2, that is sin pi is 0 by 2, and for the lower limit everything is 0. So you will get my 2 minus root 2 into x is pi by 2, everything is 0. So after cancellation it will be pi by root 2 with 2 cancels root 2 times, you will get 2 minus pi by root 2. That is our answer. That is the integral 0 to pi by 2 y dx is 2 minus pi by root 2. Let's look at our options. Our answer 2 minus pi by root 2 appears against option B. Therefore, the answer to this question is option B. That is the detailed discussion of the solution of the given problem, which is related to linear differential equations. And we have solved such similar linear differential equations many times in the past. and it is definitely one of the most expected questions. So it is a easy question. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.